If we ever meet intelligent extraterrestrials, will we even be able to talk about physics? We'll discuss this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. Physicist Daniel Whiteson and cartoonist Andy Warner have teamed up to explore one of science's strangest and most profound questions. If alien civilizations exist, would their understanding of the universe look anything like ours? Their new book, called Do Aliens Speak Physics, unpacks the nature of knowledge itself, asking whether human math and physics are truly universal, or whether even our most objective truths are shaped by our Homo sapien perspective. We'll talk about what it might take to communicate with an alien intelligence, what that might reveal about our own limitations, and how humor and illustrations can make these big questions feel surprisingly down to earth. Then we'll wrap up with What's Up with Bruce Betts, our chief scientist, as we discuss some of the hardest concepts in physics and planetary science to explain to humans, let alone extraterrestrial life. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. In classic science fiction, first contact with intelligent extraterrestrials often hinges on one very hopeful idea: that math and physics are universal languages. And of course, all of this is purely speculative because scientists have never confirmed life off of Earth, let alone intelligent life. But that doesn't stop us from asking these questions or telling these stories. In Contact, scientists decode a message of prime numbers from the stars. In Close Encounters of the Third Kind, light and sound become a bridge between our species, built on shared physical principles. And in The Day the Earth Stood Still, an alien demonstrates mastery of electromagnetic forces and advanced technology to make his message understood. But then there are stories like The Three-Body Problem and Project Hail Mary that remind us that even shared physics can't guarantee true connection. Sometimes our attempts to communicate reveal more about the limits of human perception than they do about the cosmos itself. Still, the scientific method gives us a reason to believe we're uncovering something real. Our physics doesn't just describe the world, it predicts it. Every spacecraft that lands safely on another planet, every GPS signal corrected by Einstein's theory of relativity, every quantum prediction that matches reality to a dozen decimal places. All of it is proof that our equations tap into deep truths about the nature of reality. Yet there are many ways to express an idea. And the language we choose, mathematical, visual, or cultural, shapes what we see, what we understand, and what we miss. Our science fiction stories rest on the beautiful assumption that no matter how different the beings we meet, we could still find common ground through the laws of nature. But what if that's not true? What if our version of physics is deeply human, shaped by our senses and our culture and the limited ways that we perceive reality? That's the question at the heart of Do Aliens Speak Physics, the new book by Dr. Daniel Whiteson and cartoonist Andy Warner. Daniel is a particle physicist at UC Irvine and a researcher with the ATLAS experiment at CERN's Large Hadron Collider. You might know him from the podcast Daniel and George Explain the Universe, where he and a fellow physicist use humor and curiosity to unpack the mysteries of the universe. He also co-hosts the podcast Daniel and Kelly's Extraordinary Universe with the scientist and author Kelly Weinersmith, another one of our previous Planetary Radio guests. Daniel is also the author of several popular science books, including We Have No Idea and Frequently Asked Questions About the Universe. Together with cartoonist Andy Warner, whose work has appeared everywhere from The Nib to Popular Science, and in acclaimed nonfiction books like Brief Histories of Everyday Objects, they've taken on this absolutely huge and complex question. Their book blends philosophy, linguistics, history, and physics with clever cartoons. It's part science, part comedy, and part thought experiment. A reflection on how we know what we know and what it might take to connect with a truly alien intelligence. Hey, Daniel and Andy, thanks for joining me.
Well, thanks for having us.
Yeah, pleasure to be here. Such a fan.
Thank you. It's such a trip when I meet people who listen to the show, but also, thanks for coming on as a fellow podcaster. I'm going to have to get into your show now.
Wonderful. Well, you guys talk about space and the universe, and we talk about physics a little bit, but of course, I love thinking about aliens and, everything out there in the universe. So I'm a big fan of the show.
It's funny because usually I happen upon these books because, someone that does this kind of reporting, I get a lot of books early. But in this case, it was actually a connection I had with Kelly Wiener-Smith, who's your co-host on the show. When her and her husband's book, City on Mars, came out, I did an episode with them. And like that book, this book tackles this really big idea and unpacks it in ways that might make you question whether or not your initial assumptions are true, but also takes this very interesting kind of comedic tactic with it and adds a lot of art and cartoons to it. So I just love that. And I wonder whether or not that book in any way influenced the creation of this book.
Well, any comparison to A City on Mars is very flattering. Thank you very much. I'm a big fan of that book also. And yeah, there's sort of a genre of books that talk about big questions in physics and technology, but use cartoons and humor in a way to make it accessible. You can either write a book like Stephen Hawking, where maybe you don't understand everything he says, but you feel like you were in the presence of a great man. But our approach is different. We really want you to understand what we're talking about. And one way to do that is to put you at ease by making a bunch of dad jokes and having a bunch of creative drawings. And that's why I reached out to Andy with a crazy cold email about aliens asking if he could collaborate on a book.
Yeah, I mean, comics and cartoons are just a great way of kind of like, making the medicine go down easy. And it's been that way.
You just call physics medicine.
Listen, I was raised on Larry Gonick. I read the Cartoon Guide to Physics when I was a child in the cradle. It's an old tradition, actually, these kind of books where you're dealing with really complicated topics and breaking them down for a popular audience using funny little gags. I think it's an easy in. And then it makes you, reconsider, as you said, your assumptions going into it.
Well, Daniel, you're a particle physicist, so you're deep into the wacky world of what's happening at a fundamental level. Well, Andy, you're not only an artist, but you've worked on many books that span just a wide variety of topics. And in that context, how did you guys work together to kind of unpack the topics in this book?
Oh, it was so fun. I mean, it mainly involved Daniel explaining a lot of really complicated things to me, and then us both trying to write jokes about them. And that was one of the basic ways that we worked on, is that, as you said, I'm a cartoonist. I have a pretty basic understanding of these things. And so the first step in this was Daniel actually explaining things in a way that I myself could get them, let alone draw funny little gags about them. And so that was a good filter for the project as a whole. And Daniel just has this amazing talent for taking these things that seem really esoteric, really difficult to grasp. Maybe you've heard of them in a textbook and you're like, that's way too complicated for me to ever understand. And then he finds some little example or some turn of phrase or often some gag that makes it really immediately understandable, kind of open up, unfold. So working with him on that, in that capacity, was not only fun, it was exciting because I got to learn a lot of new things in this project.
Well, as usual, Andy undersells his own contribution. I mean, he's not just a cartoonist. He has a deep knowledge of the history of science and really a brain for grasping these things. And, as well as I do, that when you're explaining something you're very close to, that you've been thinking about for decades, it's hard to take a step back and remember which parts were complicated and which parts were easy. And so explaining them to Andy helped me figure out, where is this landing for the audience? What do I need to simplify? What do I need to re-explain? Which things was I really excited to nerd out about, but actually didn't belong in the book? So the first draft was twice as long as the final draft.
The first draft was huge.
I had to cut so many darlings, but hey, maybe there's enough for another book.
Yeah.
The book begins with this kind of classic fantasy, I think, that a lot of physicists, and myself included, share, right? That is, imagine that these intelligent extraterrestrials come down to Earth and they gift us with this beautiful new physics, or at least share this common kind of scientific language. And I've often heard this phrased in the idea, math is the universal language. Yeah. Maybe we can use math to speak to the aliens. But it's a different question to ask if the aliens can speak our physics.
Mhm.
So what kind of sparked this desire to challenge that assumption and to turn it into the central question of this book?
Yeah, well, I share that fantasy, right? I mean, you and I were interested in these questions. We devote our lives to trying to unravel the mysteries of the universe. But progress is slow, right? And it's so much fun to imagine that aliens could show up and just like tell us, how does the universe work? Leap forward a million years. And I think that physicists like to fantasize about that, not just because it would be exciting, but because it suggests that we have a special role, that physics is universal in a way that biology isn't, right? Nobody expects that DNA will crop up necessarily on every planet, or, the Krebs cycle or whatever. I'm showing my ignorance of biology will appear everywhere. But physicists like to believe that we are special, the way that we used to put the Earth at the center of the universe, or imagine the humans are special. We are still clinging to that hope, physicists are, imagining that the way we are doing science is the way anybody will be doing it across the galaxy. And, I like to read about philosophy and linguistics and anthropology. And reading outside of physics and talking to people outside of physics, I realized, wow, that's not a very widespread view. Philosophers are very skeptical that our project of physics is universal. Linguists are very, very skeptical that we could communicate with aliens unless they actually show up on Earth. And so I realized that there's an opportunity there to not throw a wet blanket on this fantasy, but to inform it, to educate it, to add some nuance, a little bit of skepticism, so we could understand it better, what might actually happen when the aliens arrive.
Yeah, and I think we should probably be clear up front that just because we're discussing whether or not aliens would be able to understand our specific physics, right?
Mm-hmm.
We're not necessarily questioning whether or not the scientific method or the pursuit of understanding about the fundamental nature of the workings of the universe isn't something that can illuminate our reality, right? Nor are we definitively declaring that there are intelligent extraterrestrials. I think this is more about exploring these hypotheticals that we can challenge our hypotheses, right? And make sure that our understanding of ourselves and the cosmos is more accurate. And maybe someday talk to aliens.
Yeah, I mean, honestly, that's one of the things that drew me to the project in the first place. The aliens are cool, but it's all about the connection. It's like this extended thought experiment, where we probe all these different things that you take for granted, that our senses are the be all and end all, that how science progresses is in a rational and orderly fashion. And it kind of uses this idea of contact, of communication, of being able to exchange ideas as a jumping off point to sort of challenge all of those things. Daniel mentioned my interest in history, history of science, history of first contact is one of the things that has always fascinated me. And so taking that idea of how even humans, the Spanish were burning the Mayan codices before even bothering to read them, it gives you this place to kind of extrapolate into intelligence that is so alien from us that it is in fact extraterrestrial, right? We have a hard enough time meeting mind to mind as people.
Mm-hmm. And I think you put your finger on it earlier, Sarah, when you said this book asks a question that's related to the familiar question of, is math invented or discovered? Originally, the book I wanted to write was, is physics discovered or invented, right? And I pitched that idea to my 14-year-old, and he was like, yawn, boring. And then I thought, well, let's make the question matter. Why does it matter if physics is invented or discovered? If it works, if it powers our smartphones and takes us to the moon or whatever, then I realized it matters if other people have different descriptions, right? If when the aliens come, if our physics lines up with theirs. So then I pitched to him, what about a book about aliens arriving and trying to talk physics with them? And he was like, yeah, that sounds like fun. So my 14-year-old's are the reason we have aliens in this book.
Well, personally, thank him for me, because it was a great reframing of that question. And it also allowed you to book this book in terms of something that we're pretty familiar with when we talk about the search for extraterrestrial intelligence, which is the Drake equation, right?
Mm-hmm.
We have this way of trying to mentally calculate how many intelligent species might be communicating within our galaxy. But you extend that out. You add some factors to this equation to ask another question, which is, will they be able to understand or communicate in our kind of physics? What did you add to that equation that could allow us to ask this more deeply?
Yeah, well, we extended the Drake equation because we're a little bit pickier than Drake was, right? Drake just wants to hear from the aliens. I want to talk about, quantum field theory with them and hear about their ideas of quantum gravity. And so we need to be more refined. And so in addition to hearing from the aliens, we wanted to ask, number one, are those aliens even scientific? Like, do they do science in a way that we could recognize that's similar to our process? And then we also asked, could we communicate with them? Like, assuming that they are scientific in some way, can we make a mental connection? Can we get over this challenge of creating intermediate symbols that have all this cultural definition in a way that our ideas can appear in their minds and their ideas can appear in ours? And then we asked, would they ask the same questions? Are they interested in the same things that puzzle us, that drive us to try to understand the universe and dedicate our lives to it? And then the last piece was, would they come up with the same answers? Are there just one way to explain the universe? Are there multiple? Would they accept different kinds of answers? Could we even understand the answers? I mean, imagine the aliens show up and they're friendly and they know the answers to the questions of the universe and they want to communicate them to us and they're patient and we just don't get it. We're just like, wah, wah. Nobody here is smart enough. So we explored all of those various scenarios.
And you start each of the chapters with this kind of alien contact hypothetical, right? Something like intuition-driven navigation or bioplasma minds, right? There's all kinds of different ways you could conceive of contact with aliens going. How did you use these vignettes to kind of prime the readers to kind of question their fundamental assumptions as you drove deeper into this analysis?
Yeah, I mean, I think that they were really important to it, and they were part of the conception of the project from the earliest days. Daniel and I were kind of spitballing back and forth how to get people to engage with these projects and these ideas, and obviously gags and humor is one way, but Daniel and I are both big science fiction fans, and a lot of times kind of science fiction manifests stuff because the authors are thinking very hard about it. They're thinking about how things happen. And then later on, people get ideas about those and they're influenced by them. And so that tradition, we wanted to bring that into the book and use this idea of imagination, of telling these stories as a way to, again, probe these very specific problems that could crop up or scenarios. So each one of those hypothetical scenarios is tailored to one of the different ideas being explored in the chapters. And it was a way to kind of go deeper than you could with just explaining things straight up or even, lacing it through with a bit of humor. Sometimes it takes that imaginary leap to get the reader to really understand what you're talking about.
Because we could have just written a dry academic text on, what do philosophers think about this question? But, that wasn't the goal. We want people out there to realize this is an important question. It's interesting. It's fun to think about. And we wanted to give it to them in a way that, in a manner that they're familiar with, that they're used to reading, because not a lot of people are going to pick up a dry academic book. But, a lot of people read science fiction for these reasons. They want to hear about the various scenarios. Plus, yeah, we both like writing science fiction.
But this book draws on all kinds of different realms of science, but also anthropology, cognitive science. There's so much in here. How did you manage to integrate such a wide range of disciplines into one coherent narrative?
I did a lot of reading. Oh my gosh. I know that there's a long tradition of physicists writing outside their area of expertise and embarrassing themselves. And I did not want to add to that tradition. And so I did my best. I mean, here at UC Irvine, we have an excellent department of logic and philosophy of science and historians of science. I went and I chatted with those folks. I bought them coffee. I read their books. I talked to them about it. I really did my best because also I'm curious about this. This whole project was like an excuse for me to really answer this question myself and to learn about it. And then, of course, the terrifying moment when you send them what you've done and ask so did I butcher this or what do you think? I remember sending our book about how the mind works to Daniel Dennett and asking him for his comment. And he wrote back just 3 words. This is good. What a relief. But I also leaned heavily on Andy's expertise, right? I'm the physicist, but he has this deep understanding of history and history of science, which is very helpful.
Also, I mean, to be honest, when you have hammer, everything looks like a nail. So, one of the cool things about figuring out like a really great lens to look at stuff is that you can look at almost anything you want and sort of feed it through that and get something interesting out of it. And so Daniel's idea, or I guess your son's idea of the aliens, provided such a great structure to explore all these different far-flung corners of basically anywhere we wanted to let our minds wander was open, because so much is at stake with this potential contact that you can just peel apart different layers and dig into basically anything you want. And when we realized that, I think it became sort of this exciting thing where we could take this overarching idea of aliens and reframe it for everything from the Mayans to Noam Chomsky. It's this really, it's a very plastic idea. And so we got a lot of mileage out of it.
Yeah. Well, let's unpack some of these, hypotheticals that you've presented, starting with this idea of technology without theory, right? You kind of explore this idea that aliens could achieve something like interstellar travel through pure brute forcing it, just trial and error, rather than this kind of explanatory science. Why is the real question here not necessarily their technology, but whether or not a civilization even shares the desire to understand nature itself?
Yeah, each of these chapters is like steel manning the thing that I'm worried about. It's easy to say that, look, if these guys arrive here on Earth, because that's the premise, then they have some kind of technology to get across the stars that we don't, because we haven't shown up on their doorstep. And it's easy to go from that step to say they have this technology to therefore they must understand something about the way the universe works. Maybe they make wormholes or warp drives, or, they have something deeper that comes from their understanding of the universe. But that is a human way of proceeding, right? We have this process of building knowledge about the universe that we love. And again, we've devoted our lives to it in these professions and these cultural institutions, at least for now, that support it. And this feels like deeply wedded into the concept of technology. But, this chapter asks, does it have to be? Is it possible to be technological without being scientific? Because, there's something about being curious about the universe that feels human. I wonder about the universe. I don't think my dog does, right? As smart as my dog is. And so I wonder if other aliens, don't really care. Maybe they're like, yeah, I like getting to other stars and we know how to do it, but why do you want to know how it works or what it means or what the fundamental pieces of the universe are? And so, we did our best to argue that it's not required to be scientific, that it's possible that aliens could show up and they could know how to get here, but not know how to explain it or how it works. And maybe they're okay with that.
Mm-hmm. Yeah, I think it's good to wonder about wonder. Humans see themselves in everything. We really take it for granted.
Mm-hmm. Mm-hmm.
Yeah, I often wonder if there's just genius level cows out there in the field looking up at the sky at night, wondering why the other cows don't question the nature of reality, right? Their ability to learn more about it is one thing, but the fundamental question of whether or not they even ask those questions or their capacity to ask those questions is a totally different thing.
And of course, we don't know because the aliens haven't arrived. So all we can do is sort of well, let's look at our own history and ask, is it possible for us to do technology without science? And the answer is, of course, yes. We've been doing technology for a long, long time, and science, as we describe it, only fairly recently. So, how did those metallurgists know how to make those swords? That's sophisticated nanotechnology, which now we understand why those swords are so hard. And it comes with the arrangements of those atoms, and the impurities are really crucial. They only knew, you dunk it here, and then you take it out, and you let it cool, and you mix it with the ash, and then you dunk it again. They knew the recipe, right? Without knowing how it works, the way, you might bake an amazing cake without understanding the food chemistry. And you might not care. Right? You might be I don't care. It tastes delicious, whatever. And so we, as a species, have been developing technology without science for a long, long time. Of course, science has accelerated that, and it's so much more satisfying, but it might not be necessary.
This is reminding me of a conversation that I had with an author, Dagmar de Groot. His new book called Ripples on the Cosmic Ocean kind of talks about the ways that our universe around us have impacted the people on Earth that then drove them toward these scientific discoveries. And how without those events, maybe we wouldn't have ever come around to the scientific understanding of these things more deeply.
Yeah.
And you also explore this hypothetical of these other civilizations, right? And the ways that they were explaining the universe that maybe have been lost. But most of the way that we talk about the history of physics is in this European-centric kind of fashion. So even here on Earth, as you say, there are so many different ways that we could have arrived at these truths. And who knows what we've lost of the understanding over time.
Yeah, absolutely. It's amazing and sort of tragic to imagine, what would the Mayans be doing today if we'd left them alone? What would Mayan science be interested in? What would they have figured out that we haven't even tackled or struggled with because we've been doing things a certain way? Anybody who's done any sort of advanced math knows that like the way you set up the problem, the notation you use makes some solutions very easy and obvious and other things really painful. You choose the wrong coordinates and the problem is a nightmare. You transform it and boom, it all snaps into place. And so it's certainly possible that like Mayan mathematics is more conducive to quantum gravity or whatever. Obviously, we don't know the answer to that, but we can look back and examine the history here before there was contact. What were the Mayans doing? What questions were they answering? How did they get to astronomy and math? Is that the same as what the Chinese were doing? So we dig into all of this in the book, which was a lot of fun to read this history and also imagine. And I'm a big science fiction buff, and I remember this book by Tad Williams he wrote, I think it's called Otherland, where he actually imagines this exact scenario because he simulates all these other Earths, and in one of them, the Mayans and the Aztecs are still around, and they've developed this incredible technology, and I had that in the back of my mind while we were writing that chapter.
We touch on that a little bit with the Roman numerals and how difficult they would prove for fractions and things like that. Like the way that you represent ideas and information matters and how you're able to unpack them and dig deeper and find out more complicated paths to be on. And so this idea that there's only one route that science has taken it's completely false. In fact, it's not only that there's all these dead ends, it's almost like this one river with many streams that kind of go off and then rejoin again and again. It's like this woven thing rather than this progression from point A to point B. And that was really brought home to me working on this book. Also, the accidental nature of a lot of science, how so much of what we consider these foundational moments in pushing the collective human experience of science and the universe forward happened because of some random accident. And so if you sit with that, you realize that random accident could have happened 100 years earlier or 100 years later, or not at all, or 100 times over, right? And so the unpredictable chance of it is both exciting and unsettling. And one thing that this book does that's really interesting to me is that because we don't have aliens, all we have is ourselves, it sort of holds up this big mirror to us and has us imagine ourselves as the aliens and try on all these different alien outfits and see how they fit. And after a while, you realize how alien our own history is, that we have this experience of it, that it makes sense, it's progressive. That means that if it's progressive, it is going somewhere. And that's just false. It's this really cool collection of like human fascination building on itself.
Yeah, I think one of the most interesting courses I took in college, outside of all the rest of the things, was a course on the history of physics. And just the completely accidental nature, the strange order in which things happened, how much of the history of physics is literally just a legacy of one person handing their ideas to their next person, to the next, on these lines, right? There's so much that could have gone differently there. And if we extend that out to alien species, it's hard to even imagine what might impact the way that they develop these ideas. But you present, a few examples of this, one of which I thought was really interesting, and that, like, what if they discover quantum mechanics before they ever fathom relativity? Like, could they maybe understand something like quantum gravity long before humanity because we just happen to do it in that order?
Yeah. we're so frustrated by quantum gravity. I mean, it's been like 100 years. We've had general relativity and quantum mechanics and been unable to marry them. And it makes me feel like we're doing something wrong. You know, we're taking this the wrong way. And maybe we just got stuck because we developed these two completely separate traditions and then try to jam them together. And maybe that just doesn't work. And we got to burn it all down and start again from something else. And so, yeah, I like to fantasize that, like, if we had discovered radioactivity 100 years earlier, which we totally could have, and kicked off a quantum revolution, you know, Maxwell had been quantum, you know, and Heaviside had been quantum, then maybe Einstein would have had quantum deeply embedded in his brain, and he would have come up with quantum gravity instead of this frustrating classical gravity, you know, and all of this, of course, is just a way to wonder, like, hey, how did the aliens do it? And because I think back to that initial fantasy, like, as Andy says, we imagine the progression of science is linear, that it's one path and we're like, you know, 17 steps along it. And maybe the aliens are at step 94 and they can just, like, you know, jump us over there like a Chutes and Ladders game or something. But really it's so many different possible paths. And it may be that they show up and they're a completely different place on the map in a way that's not really that helpful to us. You know, or it could be that, like, a chocolate and peanut butter situation, that we have like some cool bit of mathematics we haven't found use for, and it like solves one of their problems, and that would be awesome, right? And so it's just fun to think about all the different scenarios, and the goal of the book is to blow your mind out a little bit and try to, you know, think more broadly about how this might go instead of just the simple linear progression and we leap forward into the future scenario.
We'll be right back with the rest of my interview with Daniel Whiteson and Andy Warner after this short break.
Hi, I'm Kate Howells, Public Education Specialist for the Planetary Society. It's time to celebrate the most inspiring space moments and missions of 2025. Every year, we invite space fans around the world to help decide the Planetary Society's Best of the Year awards, honoring the discoveries, missions, and images that made us all look up in wonder. Now it's time to pick your favorites from 2025. From daring new spacecraft to breathtaking cosmic images, your votes help celebrate the people and projects pushing the boundaries of exploration. Cast your vote today at planetary.org/best of 2025. That's planetary.org/best of 2025.
Well, you even take it down to a very basic level, and you ask questions like, is 1 + 1 equal to 2, right? Which fundamentally horrifies me, but does illuminate something there, right? And I think you give a really great human example in that you ask a question, like, say you have two objects on a desk. You've got a pen and a piece of paper, and you ask an English speaker how many objects are there. There's 2 objects. But you ask someone from Japan, and this is a funny example to me because I was studying Japanese at the moment that I began learning physics in college, and this actually stuck out to me. They would say something like, well, there is one long cylindrical object and one flat object. It's 2 objects, but it's a very different way of understanding that. And who even knows how aliens might separate objects? Which drives at an even crazier question, which is like, how do you chop up the sections of the universe, right? Is it even a linguistic difference, or is it something more fundamental than that?
Yeah, it really goes to the heart of it. It sounds like a ridiculous question, you know, and it sounds also uncomfortably similar to, like, Terrence Howard's nonsense about how 1 × 1 = 2. But that's not the issue here, right? We're really just asking, like, it's not whether 1 + 1 = 2, but, like, are 1 and 1 and 2 even concepts the aliens will have? Because, you know, arithmetic turns out to be the foundation of all of modern mathematics. This, you know, the logicians figured this out like 100 years ago. And in the tradition of, like, amazing nonfiction comics, like Logicomics is an incredible book that digs into all of this stuff, if anybody's curious about that. But yeah, we have to ask ourselves, like, how much of this is part of the universe and how much of this is cultural? And it sounds like it's obviously universal. 1 and 1 and 2 these are beautiful Platonic numbers. But as you say, there's so much culture in deciding, like, well, when do you count something as 2? You count it as 2 if you group them together into the same set. And what goes into a set and what doesn't, right? Those things are cultural. And you can wind it even further to ask, like, well, where do the idea of integers come from? Like, to have one of something and another of something. It gets down to, like, really basic questions like, well, where does my body end and the rest of the universe begin? Why do we even have that concept, right? And if you try to define it, it gets pretty slippery pretty quickly. Like, at my skin, at the edge of the dead cells, including, the hairs, or like my personal space. Like, it turns out to be very cultural. And it's not hard to go from that to imagining aliens like in a stellar atmosphere made of plasma, where like maybe the edges between their bodies is sort of a nonsense concept they never came up with. And so they don't count things the same way. They only have the reals. They don't have the integers. So you can start off thinking like, okay, that's ridiculous, man. Stop smoking banana peels. But pretty quickly you're like, hold on a second. There's a lot of assumptions here I'm making that the aliens will do things in a way that's similar to what makes sense to me.
It gets even fuzzier when you drill down to the universe on a particle level, right?
Oh,
I mean, maybe we just have this perception because of our scale size within the universe.
Yeah, exactly. I mean, at the particle level, like everything is a frothing mesh, right? It's like everything is interacting with everything, and drawing dotted lines between stuff feels totally arbitrary and made up. Yeah.
Mm-hmm. Yeah. And then there's other questions, like even if you're separating things out into regular integers and it's a similar kind of math, even within human history, like we currently use base 10 because we have 10 fingers on our hands, but I'm sure the Babylonians would throw hands over that because they loved 12s and 60s, right? Or even within science itself, you've got physicists using SI units. Meanwhile, astrophysicists are like, well, let's do everything in centimeters and parsecs and astronomical units and light years, right? Even a minor difference between those two systems could mean you land on another world or you smash millions of dollars into the Martian surface, right?
Right.
Who knows how they're doing that on an alien level. I want to believe we'll be able to do this kind of communication. And I know empirically that the things that we've learned about the universe, that the kind of abstractions we put on top of this are useful ways of thinking about the universe around us. But who knows what kind of deeper truths we could drive at if we were thinking about it in just a slightly, maybe more alien way.
Yeah, that's exactly right. As delicious as a fantasy is that the aliens could show up and we could be 10 minutes later at the chalkboard talking about Lagrangians, whatever, that's actually the least satisfying version of the story. That's sort of like traveling the world and going to a cafe in some random country and discovering, oh, it's just a Starbucks, right? It's the same as over here and there's nothing new to learn, right? And instead, it's so much more interesting when you travel the world and you're like, what? People have like spicy fish soup for breakfast and all sorts of crazy. It blows your mind because you realize I never even considered having that for breakfast. So my fantasy now, after having written this book, is that aliens show up and they don't do physics anything like the way we do it. And it completely blows our minds and shatters all of our assumptions that we didn't even realize we were making. And you're like, maybe we've been lucky in this book to identify one or two of those places that the aliens could surprise us. But I suspect when they show up, it's going to be so much more alien than anybody on Earth could even possibly imagine. And that's the greatest possible learning moment about the real nature of the universe.
What we were saying earlier about utility, I think, is really important too, right? Like, we came up with these systems because they are useful to us, the human, right? And they're useful in a human way. Like the base 10 system comes from our fingers. We're very into the planets and the stars because our neck cranes back and we're bipedal and we like to look up. And then that became useful for navigating. And so a lot of what we consider these immutable truths are basically built up from just very basic things that were useful to us. How to get someplace, how to make sure that your debt is paid off. And, if the alien is evolving underneath an ice crust or underground or has 2 digits instead of 10. They have just a very different place that they're coming from, and that might lead them somewhere entirely unlike where we ended up.
But also, human brains struggle to understand certain concepts, right? Like we are, as an example, never going to be able to intuitively understand higher dimensional spaces, right? Yeah. And we have this tendency, for better or worse, to be a little mentally lazy and just accept answers that are given to us through authority, or maybe you just type something into ChatGPT and it comes out of the black box, as you explain in the book, right? How real do you think that danger is that we'll encounter aliens and just be so underprepared, have so little capacity that we just won't understand their physics whatsoever?
Yeah, it's certainly a possibility. One reason I wrote this book is I think it might actually help us prepare a little bit. Not to be too grandiose, but like to follow the lead of biologists. Biologists have done a lot of this work already. They've imagined other ways life might be on other planets, and that has prepared us to find that life. When we send probes to those moons of Jupiter, we're not just looking for like human cats and dogs or microbes. We're imagining silicon-based organisms or ammonia-based organisms because biologists have done this work already to think outside of this human box. And so I think the more we do this in advance of alien arrival or alien message arrival, the more physicists try to crack open their assumptions and think beyond them, the better prepared we are for the day they do arrive. And also along the way, we might discover something cool. We might be like, oh, hey, we made this weird assumption in math. We didn't actually have to. This is just something we intended to go back to later and never did. And it opens up a whole new avenue. That's my own personal fantasy.
Well, there's so much math there to be discovered. I think a lot of people don't really grok that truth. They think, like, as with science, math is a logical progression from we learned this, now we make it more and more complex. But there are whole realms of math that to this day we're still learning. And some things we know are true, but we're still trying to figure out how to prove them. Mm-hmm. There's so many layers there. and humans, our senses evolved specifically for our scenario, right? For survival, not necessarily for the truth of the matter. And we live on this rock under the sun, not under an ocean, not under an O-type star, as an example. Alien senses themselves might fundamentally change the kind of scientific questions they ask as a basic premise.
Yeah, exactly, because that's how they come in contact with the universe. And so we wondered, like, well, what's the possibility that they have like vastly different senses from us? And again, we don't know and we can't really know, but we can turn the lens backward and say, like, well, what about here on Earth? What is the range of sensoriums here on Earth? And what is it like to be these different creatures? And how would an octopus scientist approach these questions? And, I read Ed Yong's amazing book about animal senses, which is really fascinating and illuminating. And you can see that, like, already here on Earth, there are animals that have senses that we don't have. Fish that can directly sense electric fields. Right? To them, they're not like invisible things that fill the universe. They can like feel them. I don't know what it's like to feel electric fields or see them or experiencing them. They have like a different qualia about electric fields. And of course, like bats and dolphins develop sonar. And so there's a whole range of ways to experience the universe. And we know that there's a lot of the universe, as you say, that we aren't experiencing. Neutrinos are everywhere and dark matter fills the universe and dark energy is making it expand. What if you could somehow sense those things or interact with them in some way? What questions would you ask about the universe? And to me, really, the philosophical question is, what answers would you accept about the universe? Because I feel like there's a way that our senses shape our understanding of the universe, the explanations we seek. I'm a very visual person. And so if you ask me like, hey, is this asteroid that's visiting from another solar system, is it going to hit us? I think the answer to that question is a map of where is the asteroid and where is the Earth and how's that all going to play in time? Because I think geometrically. But maybe somebody else thinks like algebraically, and to them the answer is like a bunch of equations on a page. Or maybe they're blind, and so they don't think geometrically, and they experience the answer and they accept the answer in a different sort of fundamental language. So I think the senses we have determine the kind of answers we find intuitive. And if the aliens have a different sort of senses, even if they're probing the same universe, they might develop different sort of intuitive answers to their questions.
Do you feel like there are any ideas that you explored in this book that personally challenged you at a fundamental level about the universality of science?
I think one of the deepest questions we touch on is something I struggle with a lot, which is, why science works at all. Like, why is it possible to write down pretty simple mathematical expressions that describe how things around us work without knowing really anything about how things work at the smallest scale? Like, we don't know what the universe is made out of. Is it strings? Is it springs? Is it springs? Is it coins? Who knows? Like, but we don't have to. Newton's laws work. Kepler's laws work. A lot of fluid dynamics work, all without really understanding the underlying nature of the universe. And this is incredible to me, right? That's basically simple mathematics. It's not just all chaos swarming all around us. And this is a puzzle that philosophers describe as the question of emergence, right? Like, if you don't understand how the universe works at the microscopic level, why is it that you can describe it at the macroscopic? And nobody knows. And to me, that's mind-boggling and frustrating and deeply, deeply unsettling.
Right.
For me, it's a similar thing, actually. And it comes to this metaphor that Daniel came up with of the quilt. And it has to do with human specialization and interest in science, right? And so we have this like quilt of scientific knowledge where different squares people have really cared about and like dug themselves into and developed these theories that make that particular thing work. But being unable to use particle physics to predict hurricanes, for example, being unable to move from one quilt square to the other, much less find the seam between them, was something that I was aware of prior to working on this book because I grew up in a family of scientists. It's in the air, but the sort of broad survey we did in this book really brought it home of how much science is guided by just human fascination, working really hard on something that you can't get out of your head. You get it to work. It's working. You teach it to somebody else, and then it doesn't necessarily follow that then fits into the puzzle piece next door. That's an assumption. That's, a leap of faith. And usually you take that leap of faith and you fall into a chasm. And that I found both unsettling and also exciting. I mean, it just means that there's so many spaces out between all the different holes we've burrowed for ourselves where you can dig someplace to connect the two burrows,
Yeah, for example, we understand fluid mechanics somewhat. We have these equations of how fluids work, and we understand crystals, somewhat, and we have the ideal gas law. So we have these different patches of knowledge about like water in its different phases. But except for the ideal gas law, which miraculously we can derive from the little microscopic understanding of the water particles, we can't derive fluid mechanics from that. We can't derive how crystals work. We just like attack it at the bigger scale and develop this patch. And as Andy says, we can't connect them together. There's just these like floating out there. We understand this and we understand that, and there's no bridge between them. And that's really incredible and frustrating that it's possible, right, to do that, to just like, I'm just going to not care what this fluid is made out of. I'm going to find some math to describe it. And it's also unsettling because you don't know if aliens are going to zoom in on the same thing. Like, is this a product of how the universe works, that simplicity emerges in some regions and escapes us in others? Or is it something about how humans are seeing the universe, that we identify these things and focus on them? And this is important to us because one human was fascinated by it. And that's why we're like fit these mathematical depictions to it. We don't know the answer to that, and we won't until the aliens show up. And then we discover, like, hey, are they curious about the same stuff? Have they zoomed in the same way? Do they think it's weird that we talk about particles and planets, or are those obvious things that are shared around the galaxy?
And if we take a step back to the initial framing of this book, that Drake equation, what do you think is actually the most limiting factor for scientific collaboration with potential aliens?
The thing that frustrates me is the fundamental structure of the Drake equation. It's all these numbers just multiplied together, right? I mean, it's a famous equation, but it's not like complicated the way like the Schrodinger equation is or whatever. It's just like a bunch of numbers multiplied. But that sounds simple, but it reveals like a deep insight, which is for this to work, everything has to fall into place. You get a single zero in there, boom, the whole thing is zero, right? That's the way multiplication works. And so like if there's just no other life in the universe, who cares what fraction of life turns civilized, Or if they don't do science, then like who cares what fraction of them would ask similar questions? So the thing that's terrifying to me is that we need non-zero numbers in every single slot for this to work. And I'm only heartened by the fact that the first part of this equation, like the number of stars and the number of planets, that's a really, really, really big number. And so maybe we'll be saved, even if the other numbers are tiny, as long as they're not, please, 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 not zero.
just a whole bunch of incurious slime molds throughout the galaxy.
Maybe.
Right, exactly. Like, how many places across the universe are there podcasts like this where people think about what else is out there and wonder? Like, that's the reason why, your efforts and this whole project is fun, because we want to know. We are excited about what's out there in the universe. And, the darkest answer to the Fermi paradox is that other people are out there and they just don't care. And in that way, we might be not alone in the universe biologically, but we might be alone in the universe intellectually.
There are just so many concepts in this book, and you take the time to illustrate so many of them. I think as we're discussing this, it sounds like it's just a super dense book full of all these really complicated ideas. But honestly, a lot of it was funny. It made me feel like it was super approachable. And I was actually quite delighted as I was going through it for my research, because every page is like this much writing and then a cool image or something. Mm-hmm. What would you say are some of your favorite illustrations in the book?
I love to draw aliens, and that was one of the big, Daniel really baited the hook when he sent me an email that said, "You want to do a book about aliens with me?" So the goopier, the better, if they're melting, tentacles. One thing that's fun to me is to just kind of challenge the assumption of like form, and maybe make them floating squares, maybe make them just goopy eyeball things. Because we were working in this sort of realm of imagination where science we were treating it as such a human concept, I felt completely free to treat biology as a human concept too, and just make the aliens as strange as I could, and then setting them in conversation with little humans. So that's a thing that I return to again and again on the page, which is funny because the whole book is like, will we be able to talk to aliens? The answer is, But again and again in the book, I have these little humans talking to aliens. And of course, that's like one of the fun magic things about cartooning is you can do stuff like that in a serious book and still get taken seriously. And so some of my favorite parts are where I was able to respond directly to the text using like some goopy alien and then some little guy, directly speaking to it.
Well, I had a great time as I'm writing, and I'm wondering like, wow, how is Andy going to illustrate this? And then I always couldn't wait for his first draft to come back where I see like his doodles, it make me laugh out loud. And they're so creative.
And then the hypothetical scenarios kind of gave me this opportunity. It's mostly gag-based, the comics I was doing in the book, but then with each of the hypothetical scenarios, I took that as license to kind of do more of an illustrated story, have these characters introduced, goof around with them, and again, really keep it lighthearted. One of the things we were trying to do with the illustrations was not have it be like the illustrations in a scientific textbook, like have it be illustrations in like the New Yorker, except with even more dad jokes, just something to like break up that big wall of text, maybe make it a little more complicated, giving you maybe something to laugh about. If you laugh about something, you remember it. And so that structure where we have about one illustration per page was very intentional too.
I had such a fun time going through this book, and we've like barely scraped the surface. So the book is out now. Please go ahead and get it and tell me online what you thought the most interesting questions were within, because there's just so much to explore here. And I think you both have laid it out in such a fun, but also existentially terrifying kind of way. So, and that's my favorite juxtaposition of things.
I live to existentially terrify.
Well, thank you so much, you guys.
Thank you.
Thank you.
We've spent this episode exploring whether aliens could ever understand our version of physics. But even here on Earth, using the same human languages, some concepts still absolutely baffle us. From quantum weirdness to planetary dynamics, there are plenty of mysteries that even humans struggle to wrap their brains around. Here's Dr. Bruce Betts, our chief scientist for What's Up. Hey, Bruce.
Hello, Sarah.
So you're one of my favorite people to talk to about science movies because they make you really mad when they're inaccurate. How do you feel about this? Which is always. How do you feel about this basic premise that if someday we meet intelligent extraterrestrial beings, that we can talk to them by sending them, say, prime numbers or trying to introduce them to some kind of physics?
Well, yeah, the basic concept, which has been talked about for a long time, Carl Sagan talked about it in Cosmos, of sending prime numbers or looking for things like prime numbers is a great one, because that's going to be true no matter what. And so if you're not just going to get a bunch of prime numbers spewed from space in a radio or light signal unless there's someone intelligent behind it, or at least we sure as heck don't know. Once you get past that, I don't, I mean, it'd be interesting. It sounds like you talked about, I don't know. It makes sense to use physics and math, since our assumption is throughout at least the part of the universe we'd find aliens, the physics is the same. How exactly you do that, I've never given any thought to, and I have no idea.
Yeah, there was one part of the book that kind of threw me for a loop. It was this idea that, maybe the aliens, if they traveled through space, wouldn't even need to know how special relativity works, because they just brute force it by hucking themselves into space. Like, that might go badly for them as soon as they realize that there's an interstellar medium. I know that it'd be really difficult to explain these kinds of concepts to extraterrestrial creatures. Maybe if they're spacefaring, they'll be intelligent enough to figure it out. But I am a bit skeptical in that there are so many concepts, even on Earth, speaking with other humans, that are difficult to explain. I've had people ask me in the past, should I go into mathematics? Should I go into physics? Should I go into astrophysics? Should I go into planetary science? And I think for me, a lot of that is not only about your passion, but about how much of a physical example in real life do you want to have in order to understand these concepts? Because at some point, when you get into that high-end physics and cosmology, and we did it, and you and I have talked about how complicated that is to try to learn. I love it, but it's hard to understand the mysteries of the universe with the human mind. So I hope someday, if we ever do meet intelligent extraterrestrials, maybe they can explain it just to us in a way that we'll actually understand, because wow.
Yeah. Yeah. Anyway, that's, I often say, and it's true. When I got the choice, that's why I became a planetary scientist, because I like the concept. I mean, I'm so boring. I became a planetary scientist who studies surfaces, because I need to be able to picture that I'm standing there, even if I know, not with all the life support, et cetera, et cetera. But and Mars is weird enough, but you start modeling the lower atmosphere of Jupiter, and it just becomes disconnected from my brain. But I'm glad there are people that can do it, and I'm glad there are people. Public loves crazy stuff like black holes, but man, they are weird and complicated, which is part of why they love it. But it frankly hurts my brain. Shall we move on?
Let's do it.
Random Space Fact Rewind.
So good, we're visiting it again. In this case, it's this one. The moon's orbit is getting farther from Earth at about the same rate your nails grow.
Nice.
Which is also, by the way, about the same rate that the mid-ocean ridges spew out lava, about 38 millimeters, 1.5 inches per year, very approximately. But I think that is trippy and weird.
That really is. No, I think about it. How often do I have to cut my nails? You can't just cut off the distance between the Earth and the moon. Also, though, kind of sad for me, because I love total solar eclipses. And that means that someday we're never going to see a total solar eclipse the same way ever again.
It's true. It does turn out to be quite far in the future.
That's true.
All right, everybody, go out there, look up the night sky, and think about what you could block the sun with if you had a large, large tube of toothpaste. Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members all around the world who cannot wait for the day that scientists discover life on another world. You can join us as we support the search for life off of Earth at planetary.org/join. Mark Calverta and Ray Paletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.